Okay, welcome to video 6 in our series of video tutorials for Liquid Physics 2D. So, similarly to the last video, this one is going to be a bit technical, kind of aimed at people who have got some coding experience. But this should be quite a bit easier than the last video, hopefully. If the last video is confusing to you, this one should be more straightforward, and it's actually a really important video as well, because in this video I'm going to show you different ways of querying the physics engine. So just finding out what's contacting what and where things are, and it's really the kind of the real meat of your game, to find out whether the ball's gone into the goal or whether the bullets hit the ship and stuff like that. Also, I have noticed a few people commenting that some of the other implementations of Liquid Fun in some other frameworks and game engines, people were complaining that there weren't, they didn't have the querying functions they wanted, or there weren't enough, and so on. So I kind of put in quite a bit of effort to give you, a big choice for querying, to have like many different ways to query the engine, so you can build exactly the game you want to build. So I'm not really going to go into a lot of detail into each method, but I'm just going to give you a general tour of most of the ways you can query, and probably what I consider to be good ways to do it. Okay, so there are actually a few example scenes already in the asset that show off some of these. So the first one I'm going to show off is a Raycaster. So if we just go to assets, or our folder, Liquid Physics 2D, have a look in example scenes. I'm going to open up this Raycaster scene. So I've showed you this before very briefly. We press play, and I just have a special kind of test script that just draws this debug information, and it prints out all this information. So you can see what it's done is we have this raycasting prefab, which I've shown you before, with the start point and end point, and we have this Raycaster script, and we're just calling a function on that. Now I'll show you that in a minute, but let's have a look at some of the debugging information we're getting here. We're getting parent index. I'll just I'll show you this in MonDevelop. It'll probably be a bit easier. So let's open up the script and have a look. Alright, okay, sorry, that's the wrong script. It's this one, sorry, LP Raycaster. Yeah, okay, alright. Duh. So I'll just show you the test script first. This is not really it's not an LP prefixed script. It's not a canon one, just kind of an example test script to show you how to do stuff. So what I'm doing is we have the Raycaster, and we're keeping this array of LP Raycast hit structs, or maybe they're structs, yeah. And what we're doing is we're just saying hits is equal to caster.raycastWorld, which basically the LP Raycaster component, when you call Raycast World function on it, it just it does the Raycast in the engine, and then returns a lot of these LP Raycast hit structs containing all information in this array. So in this test script, what we're doing is we're just at the start, we're just doing the Raycast, and then for every Raycast, we're just printing out this information, and then we're doing some other stuff to kind of to retain the gizmo information and draw those every frame as well, but we don't care about that. So have a look at the Raycaster itself. Yeah, LP Raycaster script. By the way, I'll just mention that a lot of the stuff I'm showing you in this video is going to be showing you the the kind of helper classes, the C# helper classes that you can use to do this stuff. You don't have to. You can write your own classes and just use the API functions I'm using, or use whatever API functions you want to just do whatever you want. If you do use the class I've provided, it is a bit easier because it parses the information kind of into kind of nice packages for you. Because what you actually get returned from pretty much every function that you call from C++ is just this huge array of floats. Because we can only communicate primitives back and forth. So we kind of have a system for turning everything into a float, and this we're passing back these huge float arrays. So what these helper classes do is they kind of make life easier for you by kind of decoding that and turning it into kind of human readable information. Okay, so just looking in the Raycaster, have a look at this Raycast roll function that we saw being called from our test script. So first of all, it's getting this end pointer back from the Raycast LP API Raycast roll function it's calling. And you can see the parameters here are the world pointer, which is the lpman.get pointer. That's by the way, the LP manager component keeps the reference to the world, which it's basically everything in your physics system. It's all the bodies, all the fixtures, all the particle systems, all the particles. And then other parameters like the start and finish and blah blah blah. I won't go into this into too much detail. So basically, we're just parsing all the information. We're creating new LP Raycast hits, and we're taking all those floats and turning them into actual nice information. But let's just have a look at the definition of LP Raycast hit. Let's go to declaration. Okay, yeah. So this is the information that we get back by calling that Raycast world function on our helper class. So we get a hit type, which we'll just have a look at that. And so it can either hit a fixture or a particle. So that makes sense. So this enum just denotes that. Then it has the parent index, which you can see by the comment here, indicates the index number of the fixture's body or the particle's particle system. Just if you don't not clear about this yet, that every particle system has got an index, which number it is, particle system 1, particle system 2, particle system 0, and then every particle within that particle system has its own index as well. And similarly with bodies, every body in the world has got its index, 0, 1, 2, 3, 4, whatever. And also every fixture on that body has its own index. So if a body has got 3 fixtures, it'll have fixture with index 0, number 1, and number 2. So that's what the parent index means. Then there's a position, which is straightforward, just the position of where the hit happened. Then there's normal, which is just the line basically at 90 degrees to the hit. Then there is the index, which is the index of the thing. So whereas parent index was the index of the particle system or the body, index is the index of the fixture that was hit or the actual particle that was hit. And yeah, this thing fraction, this is quite important. This actually tells you where along the raycast you hit. So you can see we're raycasting from the start point to the end point. So the fraction for this will be, something like 0.1 or whatever, or 0.2. So it just tells you how far along the raycast that it hit. I'll just talk about one more little thing about Raycast. Yeah, we can just have a look at the prefab here. You can see you have this mode thing. This is just one of the parameters that it uses when it's calling. Oh yeah, actually one other thing is this bool query particle system. This is if you want to, you don't have to perform your raycast on particle systems. So it probably makes sense. Like you may not want to, because let's say if you had a big swimming pool full of particles in your raycaster, you'll have thousands of hits that are just pointless. So if you turn this off with your raycast, and you'll see that none of these particle hits are showing up. So it's just a really performance thing. Also, the mode. So see, let's turn this back on. So see, at the moment it's on hit everything. So what it does is that it raycasts from the start to the end and just picks up every single thing in between those 2 points. Now, if we set this to find nearest, what it does is it's kind of like, if you want to know in more detail how it works, I would suggest reading the documentation on Box2D itself. But essentially what this does, it will find the closest, the first thing it hits. Now it may find a few other things because of the way it actually works, but it will definitely find the first thing. So we can see it actually found everything again. But if you, let's say, had a bigger world, and lots of things, it can just be a more efficient way to find the very closest thing that it hits. And hit anything, I think, will just pick up the first thing that it actually picks up on. So yeah, there we go. Actually picked up on two things, which are slightly confusing. So you can, okay, I think it keeps going till it finds the first body hit. So basically what this will do, it'll determine whether this raycast has hit anything, and it should just basically stop trying once it's picked up one thing. In this case it picked up two, I think because of the particles and the bodies. Okay, so that's a raycaster. Next thing is the contact listener. So there's another scene, just once again, sort of an example of this in action. So contact listener is basically a special object that you actually have in your game world, and what it does is it basically just sits there and it listens for any contacts between bodies or between particles or between bodies and particles, and it is the most accurate way to get contacts. It's absolutely deadly accurate, but it can be quite expensive, and I have to say, for particles, I think it's way too expensive, and I wouldn't use it for particles. I think it's probably too accurate for use of particles, because with particles you've got thousands and thousands of them. It doesn't have to be deadly accurate, but it's very good for fixtures, because there's some other functions that you can check every update or every fixed update and see, is this body touching this one, is it touching it now, and so on. But for, let's say, an extremely tiny short-lived collision, you can potentially miss those. Like once again, it's not really a big deal either, but if your game has to be as accurate as possible, then you can use the contact listener. So I've actually included basically as part of the LP manager. So we're just looking at this LP manager, the LP manager script, and this is the bool here to use contact listener or don't use contact listener. The default is don't, because it does use some performance, so unless you really need it, I just leave it off. So you can see in this scene what I'm doing is I basically have another one of these test scripts. So let's say contacts tester. Yeah, we'll have a look at that. Okay, and what this is doing is every fixed update, it's basically just looking at the lpman.contact listener, which is basically this public field which contains the C# representation for the contact listener, and the contact listener actually has lists of contacts that it just holds, and it updates them every frame. So we'll just have a look at the contact listener. Why not? Where is that? Okay, let's see. Look at physics 2D. Okay, LP contact listener. Yeah. So, like, this is another one of those things where if you want to know exactly how it works, I'd say check out the Box 2D documentation. But basically, what the contact listener does is that while the simulation is stepping, we call step every fixed update, which makes the simulation step through time, and then proceed forward, and make stuff happen. And the contact listener actually listens during that step. So the thing is, that's why it's super accurate, because it can pick up a contact that actually starts and ends in the middle of a step, And what it does is it just has basically lists of all these contacts that it keeps during the step, because while step is running, we can't actually do anything. So at the end of the step, once that called in fixed update function, it just then passes back a record of all the contacts that it picked up on. So that's why it can pick up on like any tiny little contact you have. And so what it does, what this class does here, the LB contact listener helper class does, is it just has these three arrays of I have fixture contacts, LP contact fix, which are fixture contacts, contacts between two fixtures. LP contact part fix, which are contacts between particles and fixtures, and LP contact part. I think these are they objects or structs. They're probably structs, but just keeps these three arrays. They're structs. LP contact keeps these arrays of these information classes representing these contacts, and every time the fixed update steps the world, these just get updated. And so anytime you want, you can just have a look at these lists and just check if the two things you actually care about are contacting. So if you want to be sure not to miss anything, then you'd want to have a look at these every fixed update. So I think if we have a look in our contact tester, yeah, that's exactly what we're doing. We're in fixed update, we're just seeing if there are contacts in this list and blah blah blah, and we're just doing it for fixture ones, and particle, and fixture particle ones. And then we're just drawing some gizmos, and we're typing out all this debug information. Just example of the kind of information you can get. For example, I'll just have a look at what kind of information is contained in these classes. Go to declaration. So yeah, here's this LB contact fix. So it's got the index of body A, the index of the fixture on body A that was in the contact. Same for body B. These manifold things are actually there's a thing called a contact manifold, which basically represents the two surfaces that are in contact. So this is basically just 2 points. They're representing those. A lot of the time, it just ends up being 1 point. And then there's the normal. So that's what I'm drawing here. These lines are basically going along the normal. So this is 90 degrees to contact. If we play the scene again, we can see when they contact, we get the normal to the contact. And then there's also a thing called is touching, which it says right now in this contact are the two bodies actually touching. Obviously most of the time you'll want that to be true to do something, But if you're using a sensor, which is you can set a body to be a sensor, or I think it actually is a fixture. You need to set to be a sensor. Yeah, sorry, you can set a fixture to be a sensor, and in that case, is touching will always be false. So if something is a sensor, just watch out for that. So yeah, now another thing about the contact listener and particles is that I've got two tiny little particle groups here with about a handful of particles in them each, and you can see they're generating absolutely tons and tons and tons and tons of contacts. So I wouldn't recommend using this for particles, but if you do want to do this, I mean, let's say you just have one particle and you want it to be really sensitive, or something in your game, you require that. You've actually got to set the material, so you can see this particle's material. It's a material I've made that I've called a contact listener, and if we have a look at it, we can see that it has these flags set: particle contact listener and fixture contact listener. Now, if these aren't set, the contact listener will ignore them. So this is a sort of a, like in the Raycaster we had ignore particles. The same thing here. If a particle does not have the flag set, then it will be ignored, and it's just to save performance, because if you, let's say, had 1,000 particles and they were picking up on particle contacts, there's just an insane amount of contacts happen in between every step, because you can imagine all the particles are kind of constantly in contact with each other. So you can see I've included a warning here, just use with caution. I think even the tooltips, expensive, use it, etc., etc. But if just for a few particles, it would be the most accurate way to find out what they're contacting. Okay, so that's the contact listener. Next thing is the particle system. So there's a bunch of different ways you can query the particle system. And I've kind of baked a lot of those ways into the LP particle system helper class, just to make life a lot easier for you, so you're not parsing these huge ints of floats. So we'll just go to liquid physics 2D, and is it LP particle system? Yeah. So let's open up this class and have a look. So, okay, so here's there are these public functions you can just call, and they'll return kind of nicely parsed information, query information. So first one is get particles in shape. So you can read the summary here. It basically well, you can read that yourself later. Well, returns an array of the indices of every particle in this particle system within the shape passed to it. Okay, so and you can see I have a note here that the first element array is the length of the array. Well, a length array -1. So what this does is you pass it a pointer to a shape, which is it's basically there's functions, more API functions you can call to get these shape things, which are in box2D, and you pass a pointer to that and its position, and then it passes back basically an array of integers, which is basically the indices of all the particles that are within that shape. And obviously you're calling it on this particular particle system, so it's all the particles in that shape in this particle system. So, let's say you might, if it was a tiny shape and only has 3 particles in it, you get an array with 3, 4, and 5 in it. So this is pretty straightforward to use. Another one is get body contacts. So for this particle system, it'll get the contacts, all the contacts right now, whenever you happen to call it. So when, at the time that you call it, it will give you contact data for all the contacts between particles in this system and bodies or fixtures. So I'll just have a look at the data. It gives you, I think it passes you back these LP system, fixed part contacts. So it passes you back basically a big array of these structs. So it's got the body index for the contact, the fixture index for the contact, the particle index for the contact. Also gives you the user data, the normal for the contact, and the weight of the contact, which is basically how much pressure is involved in the contact. So go back down. Get body contacts. Yeah, so get particle contacts. Pretty much very similar to the one before. You just call it and it gives you this list of LP system part contacts, which are similar to the part fix contacts, just contacts between two particles. So in this case, this gives you a list of these things, and if we go up and have a look at them, where they go? Yeah, here they go. LP system part contact. It's just got index of the first particle in the contact, index of the second one, and the first one's user data and the second one's user data. Like, it's not 100% necessary to get the user data. You know, you can get it yourself, but I find that this thing is so useful. I like to kind of return it a lot because I think it's the kind of, it's what you'd use really to implement, you know, your gameplay. Also, so you've seen that. Yeah, there's one other function just called get selected part details, which might be very useful. And it basically, what it does is you just pass in this array of ints, of indices of particles that you're basically interested in. So, for example, you may have called get particles in shape. It's passed you this int array with indices of all the particles in that shape, and then you want to find out about those particles. So, yeah, you pass in that array int, and then there's a lot of bools for what data do you want. Like, so do you want position, color, age, weight, velocity, or user data? So you can just say yes to all of them, get all the information, and it'll pass back an array of LP particle classes, which will just, you know, similarly to the things we've seen before, we'll just hold that data. We'll just, is it up here? Yeah, LP particles. So, you know, position, color, lifetime, weight, velocity, user data. And if you've set false for some of those bools, these will just be null, you know. Okay, so that's pretty much the particle system querying functions. Another one that's a really useful one, just a small one, is test point. You know, if you want to figure out has someone clicked on a box or, you know, something in the physics engine on a collider. I think in Unity you normally do a Raycast that has 0 lengths, you know, at a certain point. In Box2D you can just test a particular point. So I'll just see if I can actually find that. So it should be in the Liquid Physics 2D API, and it's probably in Fixture. So add Fixture. Actually, I'll just see if I can find test point. Yeah, here we go. So this API function here is useful for that. It just returns a bool. You pass in the pointer to the fixture you want to test against, the position, and yeah, just figure out whether you've hit something or not. So last one now is body get contacts. I don't actually have an implementation for this in the helper class, so if you use this, you've got to parse the information yourself. Probably something I'll add in an update will be a kind of more user-friendly way to get this. But it kind of, at the moment, I think like the best way to get contacts for just bodies and fixtures is to use the contact listener, because it's really accurate. And it's basically not really expensive at all if you're just using it for bodies and fixtures, because there isn't going to be that many of them. And probably the best way of getting contacts for particles is to use those particle system query functions that I've just shown you. But I'll just show you this one as well. So it's on obviously API body, and it's just going to be called contacts. So CONTCT. So yeah, like there's one here is just get body contact count, for example. Just if you're interested to see how many contacts a body has. But yeah, this get body contacts will just return this in pointer to this array of ints, and basically, if you read the description here, the first entry is the number of contacts. The subsequent entries are the indices of the contacting bodies. So what this tells you is you call this on a body, and you basically get to find out the indices of every body that's touching it. Okay, so that was querying, and thanks for watching.